Okay. It was okay, so you're good to go, Adrian and Nick.
Sure. Thank you, Carlos. Yep. Welcome, everyone. I'm Adrian. I worked with Nick this semester on a project that we're calling Fast Track. It's for, like you said, the pose estimation deep learning capstone that we got assigned for our Masters of Science in Data Science. And again, we've met with a lot, if not all of you, over the course of the semester. So you're all probably familiar with this in some degree. But we're going to go through it real quick anyway, and then Nick will have a small demo for you. Let's go. So again, our presentation overview is going to go over the problem that we're facing or trying to solve, the tech stack, the tools that we use to solve the problem, the current state of the solution, a quick demo, the challenges we faced, and potential future enhancements. Then we'll wrap up with the Q&A. So I could just ask everybody to hold questions to the end so we can get through it quicker. Feel free to either put them in the chat or write them down so that you can revisit them when we're done. So again, most of you are familiar with this, but the problem that we're facing, there's a need for video-based animal behavior tracking, whether you work in biology, ecology, neuroscience, medicine, etc. People do pose estimation on animal subjects, sometimes people subjects. It can be kind of cumbersome to do it frame by frame, like revisiting a video that you've taken, again, either on your phone or on a higher resolution camera, if it's all manual. Tools like DeepLabCut and SLEAP exist. They're open source, but installing them can be a little bit problematic, especially if you don't have a, excuse me, technical background. They have like dependency conflicts on your machine, and that can be that can turn people off to adopting the tooling that exists. And there's also a resource gap from local machines, even if people are able to download things onto their computers and get through all of those like technical hurdles. They still might run into the problem that their experiment that they're running or the data that they're working with is too large or complex for their computers to run on just the CPU and RAM that you have on your laptop. So availability of GPUs for parallel processing is also a bottleneck later down the road. So, excuse me, I got like a tickle cough. But so our answer to this is going to be NSF-funded access GPUs, whether it's through Jetstream or CyVerse, to remove hardware limits. And our project was an attempt at making this AI open source software more accessible to people by removing all of the technical complexity and the hardware limitations, just to give people something quick and easy that they can use out of the box. And again, I kind of went over the tech stack, and a lot of you are familiar with it already. So we have DeepLabCut and SLEAP, which are both open source software. Jupyter for data analysis and post-processing once the model's run and spits out some data that you guys can work with. Docker for containerizing these applications and making them reproducible and deployable in various like cloud environments, so you can run them locally or in environments with more hardware capabilities. NVIDIA CUDA, so again, going back to the idea of GPU parallel processing to speed things up, especially with deep learning applications. Chasm desktop to give people like a standardized desktop feel, like no different than working on your local like laptop. People can navigate and use GUIs. And then again, CyVerse and Jetstream are the NSF funded cloud platforms where these can be hosted. Nick, if you want to talk about the process we went through.
Yeah, for sure. So yeah, now we'll just go through the process of how we got or created the apps for each of these for CyVerse and Jetstream. So we took two different approaches to do so. So to create the CyVerse apps, we used Docker containers, which started by identifying an appropriate base image that allowed for CyVerse compatibility along with GPU use. And once we found this base image to use, we then installed NVIDIA and CUDA dependencies and configured the GPU appropriately because CyVerse requires a specific NVIDIA driver. And it actually is kind of, this part has kind of changed since we first created the containers as a result of recent CyVerse updates. But when we initially made it, it was required that we had explicitly specified the NVIDIA driver for the container. So after doing that, we installed the necessary libraries to enable the GUIs for Sleep and DeepLabCut. This was followed by the installation of the Sleep and DeepLabCut softwares themselves. And then we also added some additional features such as Jupyter, FileZilla, and MVI Top for post-processing analysis, file management, and then GPU activity monitoring. And so for the Jetstream approach, this was a little different. So we started with just creating a Jetstream instance using the Ubuntu 24.04 image. And then in that image, we installed DeepLabCut, Sleep, and all the other tools, the Jupyter, FileZilla. And once we had all of those properly installed in this instance, we created the snapshot image from this instance, which is now used as the base image for users to create new instances with these softwares installed. And so after we had this, we then used Terraform to build a template in Cacao to launch new instances. And if you go to the next slide, Adrian.
Sure.
I guess this just goes right into my demo now. So I'm actually going to go ahead and grab the screen from you if you don't mind.
Sure, I'll stop this quick. Go ahead.
All right. So now I will walk through how to launch each of the apps in CyVerse and Jetstream. So we will start with CyVerse. Here, you will go to the discovery environment, which is linked in our documentation. So you'll be able to, it'll take you directly here. If you don't have an account already, it's free to sign up. And we also have documentation that walks you through how to sign up for an account. And so once you've set up your account, you can navigate to the discovery environment and then go over to apps. And from here, you can search for whichever app you're looking for. We'll do Sleep, for example. And here you can see there's multiple versions. So the latest version of Sleep, that's 1.4.1, is a beta version that's still in development. So there's some bugs that occur during training. So therefore, we created another container with Sleep version 1.3.3 as it's more stable in training and you don't see those bugs. And so when configuring the Sleep environment here, you would specify the minimum memory to be 64 gigabytes. And then you can press next and you can go ahead and launch analysis. I'm not going to do that because I already have one. But when you do launch the analysis, it will take you to a screen that looks like this. And you would press go to analysis. After that downloads the container, it will open this desktop. And you will see this window that pops up with instructions on how to load the Sleep software or the Sleep GUI. One of the ways to do this is to double click on the desktop icon here. So pop up a terminal, which loads the GUI. It takes a second. But once it does, you will be able to see Sleep here. And from here, you'll be able to create new projects or open existing projects. I'm not going to do this at this moment. I'll do that in a second in Jetstream. So after you perform your analysis in the Sleep GUI here, you can go over to the Jupyter notebooks. We have a desktop shortcut to this, and this will launch the existing notebooks. These are actually from the original Sleep GitHub repository itself. So once you have the output files, the H5 files or whatever else it may be from the Sleep analysis, you can go in these and perform whether it's model evaluation or creating additional visualizations. And so these notebooks exist here, so you don't have to export the output immediately from Sleep. But when you do want to export the output, then you can go over here and we have a FileZilla application installed, which allows you to import, upload, download, or do file management to remote servers. So it just removes some of the hassle involved so you don't have to connect to OneDrive or Google Drive or anything like that every time within the container. And so that is Sleep. And then for DeepLabCut, it is nearly an identical process. So you will go to apps, you will search DeepLabCut, and then you select this app. And for this configuration, you don't have to specify anything in the memory or CPU cores or any of that. You can just go ahead and launch analysis. which again will take you to a screen that looks like this. And then when you press go to analysis, it will take you to a different desktop. And this time you will see this. And then the other way, as I mentioned, there's a couple different ways to launch the application. So a different way to do it is to open the terminal and just follow the instructions shown on the window. And then this will again load the DeepLabCut GUI. It'll take a second, but once it does pop up, again, you can go ahead and just create a new project or load an existing project and perform your analysis in here. And again, then after this, you can go ahead and use the output files from DeepLabCut to, there will be Jupyter notebooks in here as well, and also the FileZilla for importing and exporting files. And so that's how you will access the CyVerse apps. And now for the Jetstream applications, you will go through Cacao. And so after setting up your account on here, which again, we will provide information in our documentation on how to do that, you will come to the Cacao homepage, and then you will go over to templates. And then you can see it here, but you'll probably have to search pose estimation, and you will select this template and deploy. And then so you will go ahead and select your project of your allocation if it wants to load. Good. Okay, this isn't going to load. So what will happen is a template will pop up with different parameters, and you'll be able to specify, for example, the amount of instructor instances or student instances, and then you can include student usernames for whichever students will be using the instances. And the one thing I did want to show you is you will have to select a parameter. There will be the last parameter in the template will be the size of the machine created, and you'll have to do at least a G3 medium. So that'll allow you to use your the GPUs to speed up the processing. But once you launch that, it'll take you to a desktop that looks like this. And so here you'll be able to see Sleep, DeepLabCut, Jupyter, FileZilla. You'll see all the applications here. And so here, for example, if we were to do a sleep analysis, you would press this, and it will again pop up a terminal that loads the GUI. And once the GUI is in here, you can go ahead and open an existing project, which we have for now. Or if you created a new project, then you would go through the steps in our documentation to upload a video and start from there. So here we will look at this first. And so here, once you load your video, you can see, for example, some of the frames will pop up here. And so what you would do to label the frames is you would select right click on a fly. For example, you could do force directed, which is one of the easiest ways to do this. And then you would go through and label each of these body parts. And I'm not going to go through all of this right now for the sake of time, but this is just a quick demonstration of what the frame labeling process looks like. And once you do go through that, you will see your frames will look like this with each of the flies labeled. And usually on average, it's about 20 frames that you'll want to do. And so once you do have this, you have all your frames labeled, then you can go ahead and run training. And again, there's more documentation on an in-depth process of what each of these parameters means and what you should do for your specific project. But here, for example, we have a multi-animal top-down project. And so we would predict on the user labeled frames. Again, this will typically be about 20 frames. And then you can go through each of these additional configurations to specify the appropriate parameters for your specific project. Let's pull, okay. Okay, this does. I'm not going to run this right now because for the sake of time, and we already have this. So once you have these, I guess I have to. I just not. Okay. So there we go. So then once you configure it appropriately, then you will be able to go ahead and run the training, which I will not do right now because it takes a little bit. But once you do that, then it will, when that finishes, I'll pull up the project with the labeled frames and the inference is done. All right, so once the inference is performed, then you can see the model's predictions. It'll again bring you to this in this labeling suggestions tab. You will be able to see the predicted points for each frame. And so from here, you can also, in this tab over here, you'll be able to see a mean score. So ideally, you'll want about a 0.95 mean score, indicating that the model did a relatively good job. If you don't, then you can go back and retrain or try different training parameters to make the model's performance better. And so once you have it to level the model performs to the quality that you want it to, then again, you can go ahead and go over to the Jupyter notebooks that will be preloaded in here. And you will take again the H5 files to perform additional analysis to then create visualizations to monitor the fly's movements or velocity or any other variables of interest. And so that's a brief overview of how to access the tools through CyVerse and Jetstream. Adrian, if you want to take it back here.
Yeah, for sure. Thank you, Nick. Take it back. So we'll go back here. And again, this is all of what Nick just went through of our current state. So I won't go through this as much, but again, just to reiterate, is that we have multiple platforms that we offer these tools through, or tool benches, if you want to call them that. Previously, one of these solutions already exist in HPC. It works, but again, GPUs are a scarce commodity. Everybody wants them to speed up their workflow. So again, offering these on different platforms gives you more options and kind of lets you be flexible with your workflow. So I'm going to escape out of this real quick to demo. That's what we just did. So again, Nick kept referring back to our documentation. He kept saying, this is no documentation. So if I go here, so we had to maintain a GitHub repository to get credit for this course, and it kind of lent itself well towards this, in that we could throw everything that end users would want or need to know into this one-stop shop to go through here, set up their accounts like Nick was saying for the different platforms that we're offering, and then go through an analysis. So everything that Nick just went through is all written down here in various capacities. So again, if we just give somebody this link to get to this landing page, if they already know what they're looking for, they can just go over here to this pages bar and go directly to, again, if it's account setup or using the actual apps, they can go through, they can determine if they're unfamiliar with what they should be doing. If they weren't told by a professor, they can go here and decide for themselves the pros and cons of using each platform, using each piece of software. And again, this goes through and is our sales pitch for what they should do. It kind of reads like a story. You just go to the next step if you know what you're going to do. Go here again. There's photos, and text. We circle things and try to make it as straightforward as possible for people setting things up. We have a couple of things that we still have to modify on this to make it more verbose and really make sure that people get as much as they can out of our documentation. And then I will go maybe to the sleep one. And I put here under construction. So again, we're wrapping this documentation up, and then same thing, you go here, and we'll have to modify it based off of the things that Nick just shared as well to make sure it's got the most up-to-date information. But it goes through and it shows you, how to go through a whole analysis like Nick just showed with step-by-steps. I have to put in more text here again to make it more straightforward, but placeholders in here right now. This will be ready shortly for us, and then takes you through the whole thing, beginning to end, and then how you'd actually go about doing the data analysis afterwards. So it shouldn't require any meetings from anybody, any like face-to-face explanations of anything. We really tried to make it as simple as possible so that people can just take the link for this and go end to end on their own with very minimal hand holding, if you want to call it that. So that's here. So that's our end user documentation. And then we also went everything that we did to get to this point, we put into this repository as like developer documentation, or like technical contributor documentation. So that's over here in this code section. So people that are doing their analyses or using it for research might not be concerned with this. But again, Nick and I are capstone students. We're available to be contacted to answer questions about this, but we won't be working on this project forever, right? Especially as we wrap up the semester. So for the next person that comes into this space that wants to expand upon what we did, or if they want to reproduce it in order to do it better in some way, everything that we did is in here. Again, they have a README for landing page, how the repository is organized, contributions, how we expect you to contribute, workflows, etc. So again, if we go up here into analysis, and you can see data, which is kind of sparse. We didn't really store any data in here because the files that we were working with were so large. So we'll, excuse me, link to our data through this one. I need the Docker files. Again, we have SLEAP, DeepLabCut, Diplomat, which we worked with Isaac Robinson on that one. which is still in development. We're still working on that one, but anything that's current state that's been deployed to an environment, or we have this archive folder for iterations that we did to get to where we were at. Those are all going to be in there and documented. If I go back, documentation. So again, we have documents for environment setup and like the case for like dependency management and package managers, how to get things into CyVerse, how to do DeepLabCut, and go through an analysis and how it all works, how Docker works, how the GPU acceleration works, Jetstream and Cacao, Jetstream just installation, again, to Nick's point, like how you get to that point and install everything, just some machine learning know-how. If a student's contributing to this and they don't necessarily have that kind of background, but they need to be able to explain or like teach somebody that's less than, like has less technical knowledge than they do. And then the same thing for sleep. So again, anything that we went through over this process is going to be in here for the next technical contributor. And then Docker files Terraform. So the Terraform, like Nick said, that takes the template and deploys it to Cacao. All of that information is also in here for to be modified if any infrastructure needs to be updated. Nick, is there anything else within the repo that I'm missing that I should point to, or?
No, not within this. I'm gonna grab the screen back in a second when you're done with this though.
Sure, I think I'm done. Let me stop sharing. Go ahead and grab it.
All right, so just real quick, this is what I was mentioning about the template in Cacao. So it finally loaded here. So you'll select the template and then you'll go to next. And here you'll be able to label your instance name. And this is what I was saying about you'll be able to specify the number of instructor instances. And this is just a base template. This is not the final template that we'll be using for this. You'll be able to specify the amount of student instances you'll need as well. And you can specify the student usernames for each one of these. And this is that parameter that I was talking about. For these applications, you'll have to use at least a G3 medium to properly perform training with the GPU. And then you would press next and submit. And once you do that, then you can go over and it will show up in your deployments and you can see the instructor instance and then the student instances. And then to access the web desktops, you would just go over to the web desktop icon. And then this would take you to the desktop that looks like this. So I just wanted to go back and reiterate that. All right, Adrian, you can grab that back.
Yeah, let me grab it. So again, we just went through our demos of the end user documentation, the technical contributor documentation, and the actual tooling itself. So again, this wasn't without challenges or hurdles that we had to overcome over the course of the semester. So some of the challenges that we identified as we were developing this were leveraging existing Docker images. So at first we thought that we had to do it from scratch, and we didn't realize that both the community that develops these tools, as well as some people internal to the University of Arizona, already had some work in this space. So we spent some time trying to do it from scratch for a couple of weeks before we ended up doing some research and realizing that some people had already taken some steps for us that we could leverage those and get like a running start. So we kind of pivoted and combined some things that we had working from our initial scratch work that we did and these existing images. So again, just knowing what was available to us was a challenge in seeking those things out. Actually learning the software. So again, we hadn't any experience with pose estimation, DeepLabCut, or SLEAP prior to this course. In January is when we started it. So just learning how those things worked, what pose estimation was, how to actually go through and use the software, learn the interface. Those were all challenging. And again, we had to visit various resources from their like official documentation, and then some like community, like even like Reddit type of things, like learning how to do things, people running into issues and overcoming those. Picking a base image that keeps both Chasm, which is our desktop environment, that Linux environment that we were showing you, and the GPU happy. So again, Docker works with layering images on top of each other, and it can install things through a base image so that you don't have to explicitly add things that can do most of the work for you. But again, leveraging both things, having a clean user interface for people to not have to worry about like technical things and just have like a very seamless like interaction with it, but also leveraging those like hardware capabilities. Like those things didn't necessarily like each other all the time. So figuring that out, environment setup. So we had different options of using Conda, Mawa, and just Python like virtual environment. And again, they all have trade-offs of good things and bad things about them. And there's different package availabilities, especially when you're installing DeepLabCut and SLEAP through them, and like how that actually, like what they have available to them, like versions and stuff to install. So just again, learning those different dependency managers and environment setups. To Nick's point, GPU drivers. So again, we worked through this CUDA and NVIDIA drivers and dependencies, making sure that everything liked each other, was exposed in such a way that you actually had access to the like hardware that's available to you through these cloud platforms. Machine learning library conflicts. So again, there's like a three-body problem, right? Where like two libraries can interact with each other like through versions, but then like if you add a third one in there, like then it causes some complexities that again, non-technical users trying to work through these kind of get defeatist and like give up at this point. So just making sure that we did research and knew like, okay, this requires whatever version or higher, this one needs whatever or lower, and just finding like that sweet spot of like what makes everybody happy and what makes it work seamlessly. And then dialing resource requirements. So we ran into a couple of issues where we would run a training on something and we'd hit like a limit or like crash the app because of the size or like the nature of the data that we were working with. So just making sure that we leverage the actual cloud resource that were available and could scale it up and like determine like what the baseline that we need so that a user coming into it knows that they need however much RAM in order for their videos, or how to actually calculate some of those things so they could use the minimum possible and not overuse it, because that's like another like tragedy of the commons problem within these cloud resources is like people using too much and then not enough to go around. So that was also a challenge that we kind of had to play with some. So again, we are coming to the end of the semester. We didn't get through everything that we necessarily wanted to or that could be done in this space. So we kind of thought of some potential future things that can make this better, and that will leave that for the next technical person that comes to work in this area. So one of them is a unified image. So if you remember Nick going through CyVerse and he showed different apps for SLEAP and DeepLabCut, you had to launch them individually. And you had to know ahead of time like that you wanted to work with one or the other one. So a unified image could exist where, and part of the reason why we don't have that currently is again, going back to that like dependency version conflicts that we're alluding to, that we resolved a lot of them, but like some of them are still between SLEAP and DeepLabCut, needed some like working with. So we could get to a point where you'd have just one app within CyVerse or one unified image where you can launch everything and everything exists and you don't have to do it once and they all play nice together and live in harmony, so to speak, with a Python version of greater than 3.10 for like future proofing it, if you want to call it that, because it's got to be more modern and supported than some older Python versions. Diplomat integration. So again, we had worked with Isaac Robinson on this. He was very gracious with his time, and got to a point where we had this that could run locally, but we were running into some issues, I think, with getting it deployed or getting it working in one of those cloud environments, due to, again, some like driver issues or mismatched compatibilities and stuff like that. So it is in a good state right now, but not in a state where we're able to deploy it. So again, that's going to be in our GitHub, what's documented and like what next steps would be for doing that. And again, we would pursue that if we had more time. Auto builds, excuse me, auto builds on upstream changes. So again, both of these software are open source, so they're constantly being improved upon. And if a new version came out of them that was compelling or people wanted to leverage the new capabilities, we'd have to redo all these steps that Nick and I did, like taking that new version, pulling it, building a Docker image for it, and then deploying that. And you can automate that so that as soon as the open source community pushes again to one of their production, if you want to call it production branches of the software, that it just automatically goes through that. So there's no manual technical work to be done to leverage or to pull in those latest versions of those software. You just get it automatically. A slimmer Docker container. So one thing that Nick and I ran into while we were doing this was the Docker containers and the images could get quite large, which again takes time to pull them if you want to pull it onto your local push them up. If you're developing it, you need to get it into a cloud environment, and just like running it and building it just generally. And so there are ways you can layer things in a certain way, cache things, and do some like optimization for those things to build and to upload quicker and to take up less space. And we played with that some, but not to the extent like we wanted to get our MVP up and get like some like something that people could work with rather than like an optimized super fast Docker container. So again, that's a good feature enhancement for people that have the time to do so. Actual modification of Sleep and DLC software via Git fork. So again, they're open source. You have the ability to fork these repositories to actually make actual changes to the software that exists in them, so that they behave a certain way. The GUI's laid out a certain way. They do certain things, and you can actually modify that or change that if you have the machine learning technical know-how to do so. We didn't touch any of that with ours, but we did see both like online in forums and as well as some of you guys as our stakeholders and users were running into issues with how the actual experience was with it, and that is changeable. And again, we could do that in one of two ways. You could Git fork it and then build these Docker images based off of our modifications, or conversely, it would take a little bit longer, but you could pull request and like propose modifications to the actual open source software, and then the maintainers could take those, review them, and then if they determine that they're good or valid or legitimate, they could take those and incorporate them into like the official Sleep and DeepLabCut software that everyone uses. So again, that's like a way above and beyond thing, but it is possible, and it could be an area for future researchers that find themselves in our shoes to pursue. And then here's a kind of a neat one that's novel with a lot of the generative AI and LLM tooling that exists nowadays, is adding LLM. I can't remember what the name of it is. There's one that exists already for DeepLabCut that you kind of just put it in as a plugin on top of DeepLabCut, and then you're able to ask questions about the output of the models. And it, like just in English, you could ask it about things that happen with it, or the data output, and it gives you like a chat interface for doing that. And again, that would be like a nice to have. And some things exist with that already. We didn't really pursue that or look into it, but given that, like, again, the whole concept of this is accessible AI, like the more that we can do to abstract away technical complexity and just make it as seamless as possible for people to go in and do the research, and not have to worry about all this other stuff. That's kind of the dream, right? So if I go to the next slide. Okay, I think that brings us to the end of what Nick and I had to share with you guys. So if you guys had any excuse me, questions that you had over the course of the presentation that you want to bring to us now, we'd be happy to answer those. Yeah, Edwin.
Hey, so I would just like to comment that I've been very impressed with both you, Nick, and Adrian. You know, not only did you have to learn how to stitch all these things together, but learning how to deploy these apps on two vastly different cloud infrastructures, and then learn kind of the tooling to do so. It's very impressive. And like all this, despite having all the challenges that you encountered, I think some junior developers would have taken several months just to learn like one cloud, but you did it in less time learning two clouds. So I think you guys should give yourself a big pat on your back, and you know, especially for wrapping it up despite like not having finished like everything you wanted. I guess one question I would ask, like, you know, what would you say is like the most surprising piece of your project? Maybe like that gave you like the biggest aha moment, or maybe was the most exciting thing that you did on your project?
I got one. Sorry, do you want to write, Adrian?
No, I was going to say, I was going to throw that to you in a second, but I did want to take a moment to thank Edwin, Michele, and everybody. Again, I won't go through and name everybody because we got a lot of help with this, but we do appreciate your shout out and your kudos that you gave us. But again, we couldn't have really done this without the help from a lot of other people. So again, everybody else that helped with this, Isaac, I don't know if Isaac's here as well, but again, he was very gracious with his time and helping us through some things. So, you know, we made it work. We hacked it together, and I think that we're happy with the outcome of it, but it wasn't a solo effort or a duo effort, if you want to call it that, on Nick and my part. We did leverage a lot of your guys' time and expertise as well. We're very gracious for that. So thank you, guys.
I was going to say the same thing. Yeah, big thank you to everyone that helped. especially our mentors, Carlos and Rob, and also Michele, Edwin, Isaac, Martha, Anna, everybody else that helped. Thank you for all for your resources and time. We really appreciate that. Back to Edwin's question of the biggest aha moment. The first one that comes to mind is with one of my like 7 hour long sessions with Michele when we were trying to figure out the Docker containers. So we originally were trying to do Docker for both CyVerse and Jetstream. And then it was like, I think 3 p.m. on a Friday. And towards the end of the day, Michele was like, why are we using Docker for Jetstream? And I was like, what do you mean? And then he started telling me about the virtual snapshots in Jetstream. And that was much easier to work with because we were running into, there was some authentication errors and segmentation faults trying to use the Docker containers in Jetstream. And so it became much easier. And that was a big, big aha moment with the virtual snapshots for Jetstream.
Yeah, I'll do a small one. So I think Nick alluded to something that's probably worth pointing out is that we put a lot of long nights, a lot of time into this. So like I would work on this into whatever 11, 12, 1 a.m. type of thing. And I think that my aha moment, I can't remember which thing it was in particular. I think it was working on sleep and trying different things within the Docker file to get it to run and to pull different things and use different dependency versions and stuff like that. And I just kept iterating over it. I'd try to build it, get it to go. It would cache some things. It would get to a point, it would build for like 20, 30 minutes and then break and go again. And I got to a point at, again, like 2 a.m. one night on like a weekend. And I was working on it and I finally got it to go and it worked. I was able to launch it. I don't remember exactly what was the thing that got it to work, but as soon as I did it, I messaged Nick and I probably used some profanity in my message to Nick. I was like, I did it. It's over. We got it. And then, Nick messaged me back and he was up because of the time difference between where I live in Arizona. And, we were super excited about that because it was a big breakthrough. We're getting kind of worried about the state of it. That was a big thing. And Nick, I don't remember what it was that was the breakthrough, but I remember the feeling. And I think that was the important part.
Yeah, 100%. I mean, there were a couple of those moments for sure. I do also just want to add, Martha, I know you're here, and I know a lot of the issues you were talking about were related to the actual using the sleep software itself, whether it was the output files that were just, there was the same file being output every time, or those are the re-encoding issues. And we unfortunately didn't get to spend a whole ton of time trying to resolve those issues because our big battle was trying to install the whole thing in a Jetstream and CyVerse. But that is, I just wanted to say that is one of the things that we can pass on to the next people that work on this project is trying to go in and modify the actual problems with the software itself.
No, I also wanted to say I'm really impressed with all the work that was done and just the organization of these, containers or snapshots and stuff, I think is going to be extremely helpful for students that are new to this, trying to get started. I wondered if you, if you consider like an undergraduate junior with some technical background, but not a ton of coding experience, how comfortable do you think someone like that would be walking into using your work? And were you, I know you were thinking about the design of this so that it could be user friendly, but like, what are the features you think would make it, that would be like the things that make it simplest for those students?
I think the biggest thing for them, this was also in Anna's lab when she had talked about her. The biggest thing for with the students with the non-technical skills in computer science was the installation and working in the terminal and trying to get all the libraries and everything they needed installed for SLEAP and DeepLabCut. And so the biggest thing we did was just eliminate that process. So now you can just go in and click on the desktop icons and it's installed for you and you're ready to use it. And then as far as the actual using the software itself, that's kind of where the actual docs from the SLEAP and DeepLabCut get involved. But the thing is, well, there's also the option to do it through, you can do like the whole analysis through Colab notebooks or something like that. But with these GUIs, you don't need to do that. And I know you had, so I talked to Malia when I went to one of your labs. She was telling me that you had one of those, the Jupyter notebooks. And so if you wanted to, you could also install that into the CyVerse container or the Jetstream instance to have your own modified Jupyter notebooks for that post-processing.
But I think that's a great addition, is just to be able to have the students not have to download the analysis file and upload them into Colab, but Colab was the platform that was just available. But so I really like that. So thanks for doing that.
For sure, for sure. I think if there's no, go ahead, Carlos.
Any more questions? No? looks very easy to use, right? Except when you start trying to use it.
Exactly, yeah.
Well, Carlos, I think we're going to try to beta test this right away because Malia, who Nick just mentioned, is actually going to be doing some work following up on a lot of the videos that the students took during the semester, trying to get things organized and analyzed, and then maybe trying to get the DeepLabCut software to work as a layer on top of that. So I think we're going to try to, kick the tires on this pretty soon. So.
Okay.
Awesome.
And Nick and Adrian, how far was the Diplomat installation on site?
It was going to be the next. So I mean, it was the next step. So we got Isaac helped us out a lot as far as creating. He made some containers and some Docker containers that had Sleep Diplomat and DeepLabCut Diplomat. However, to use them, he had used Docker Compose, which is not compatible with CyVerse. And so what we were going to do is try to take the working parts from his container and implement them into a CyVerse compatible container. We just did not get to that point.
I should still be sharing my screen, but so we took what he gave us and threw it into our repository. We're documenting it currently, like the state of it, like what Nick just said about what's not compatible with it and what you'd have to change to take what he has that is working and kind of mesh it with what we have that's working in our CyVerse and SLEAP environments. So
I can give a minor input on that. This is Travis. Isaac works for me. He has, since working with the two of you to develop that container, he's spun off a modification of Diplomat that no longer requires that DeepLabCut or SLEAP be installed in the environment, which makes for a much easier setup. So that it could actually be set up as its own Conda environment inside of either one of these images. I know you're about to the end of your semester, but that's a much more straightforward step, I think, to move it forward.
Yeah, that was definitely very big because part of the issues with that was we needed Python 3.7 for SLEAP. But if we didn't need the SLEAP front end, then we would just be able to use Python 3.10 for Diplomat. And if it's separate, if you can do it in separate environments, then that would be huge. So we'll put that in our documentation then, Adrian, as far as the next steps where to go for that.
yeah, sounds good.
Okay. All right. Very, very interesting and useful. And we will have your emails for further questions and future collaborations. So, well, thank you for attending and kudos to Nick and Adrian. And thanks for connecting. Okay.
Thank you, everyone.
You.
Yep. Thank you, everyone. We appreciate it.
Hey, Nick and Adrian, can you share some of your slides? I mean, I would love to actually have a copy of that presentation. So if that's allowable, that would be fantastic.
Yeah, that's good.
Yeah, I can take it and share it with your email, I think.
Sure, that would be great.
Yeah, I'll give you, do you just want read access to it or do you want write access as well?
Oh, just read access, fine. Yeah.
We can actually probably throw some links in there too, as far as the repositories and the apps and all that.
Mm-hmm.
Yeah.
Okay.
You
Yeah.
have the GitHub repo for the project, and also I'll be sharing the recording and a YouTube video in a week or so.
Okay. Sounds good. And yeah, I copied out the GitHub links, so I've got them.
Okay. Well,
Okay. Thank you all. Bye.
Thank you.